All right. Well, good afternoon, everyone. Thank you all for joining us for the first session of the Technology Association of Iowa's Cybersecurity Intern Series. My name is Molly Ross. I'm the Vice President of Operations at the Technology Association of Iowa. And I have the privilege of part of my role in working with our CISO Roundtable. That is a group of the cybersecurity leaders at a number of companies across the state of Iowa. And they're the ones that really put in the work to put this together because they want to ensure that we have the bright cybersecurity minds growing right here in Iowa. So thank you all for joining. Thank those of you who have helped pull this together that are on the call. Thank you for helping us put this together and being able to offer it this summer. As I mentioned, this is the first of 4 series. Hopefully you all are signed up for each of the 4. Everyone who does participate in 3 of the 4 sessions will earn a certificate of completion for taking part in this series. So be sure to make sure those dates are held on your calendar. This will be, obviously, as you all can tell, all of our registrants can tell, you are muted and your camera's off, but we do hope that you will participate in today's conversation. Please feel free to put questions in the chat as they come up. This will be a pretty free-flowing conversation once our panelists get through their introductions. So feel free to drop questions in there at any time they come to you. And with that, I'm going to turn it over to our moderator for today's session, James Boyd with Shazam. James is also the chair of the CISO Roundtable that has helped pull this together. So thank you, James.
Yeah, thank you, Molly. And yeah, first of all, welcome everyone to the Cyber Intern Series. As Molly mentioned, I'm James Boyd. I'm the VP of Information Security at Shazam. So if you're not familiar with Shazam, first off, no, we are not the app, the music-related app. We're a payment processing company that provides a few other software services and multiple services to banks and community credit unions across the country. So I have to give my little plug there for my company. But just as everybody that deals with information electronically, information security is a big deal to us, and continuing to mature our security program is a constant thing. Of course, there's always more to do in information security all the time. So as Molly mentioned, this is the first of 4 sessions that I think really offer some good insight into the world of cybersecurity and into the jobs that are available in that exciting industry. So really, if your career aspirations are cybersecurity, there truly has never been a better time to get into that line of work. It's difficult to find cyber talent right now, meaning that there's a lot of jobs available and not very many people to fill them. So if you're going through college right now and attaining your degree and looking to work in that field right now, the market is very bad for me as a hiring manager and very good for you coming out of college looking to get into that field. So it's a very, very exciting field and growing all the time. So today we have 3 speakers representing 3 key job areas within cybersecurity. Each one of them will give you kind of a taste of what their particular position is like, and they'll probably be able to explain how they've worked their way into their current roles. And we do have a relatively small group of participants today, so please feel free to enter questions into the chat. As Molly mentioned, this is more valuable, I believe, the more interactive it is. So I'll introduce each speaker, and then we'll take questions at the end. So again, feel free to enter them into the chat as we're going along, and then I'll bring up each of those questions with the speakers at the end of their turn of talking, and then we'll keep moving between speakers here. So first of all, we have Adam Lernahan, who is a senior IT security analyst at the University of Iowa. So Adam, go ahead.
Okay, let me, I can share my screen here. Okay, so, sorry, let me just get my notes here. Okay, so I've been working at the University of Iowa for the last 5 years. Before that, I worked at ACT for 3 years, doing security there. And so I started out, I went to school at Western Illinois University, was a PC tech there, moved to Iowa City, became a PC tech at ACT, and then jumped over into security at ACT, and then went to the university. So I've been doing security for about 7 years now. And I have to say, it's a great job field to be in. There's always new things, and it's always exciting. Well, to me, maybe just, some people may disagree. Anyways, let's just get into it. Okay, so what do I do during the day? Some of the more common things that a lot of people will be doing is meetings. I have like an endpoint meeting. So I am the endpoint lead at the University of Iowa. So I'm the one who has to not manage all of them, but I'm the head person of the security for all our endpoints. So yeah, there's one thing I do. And then the other meeting that I really like is threat hunting. And so what we do is we meet as a group, the whole team, and we figure out ideas on what to look for, any bad things in the environment. So like any possible CNC traffic or phishing going on, or anything really that someone has an interest in for that day. We do that once a week. And then more common stuff, just tickets and emails, with general security questions, AV exclusions, AV performance issues, phishing emails we get a lot of, and then IOCs. So what IOCs are, if you don't know, is indicators of compromise. So what that is any new possibly bad IPs or bad websites that are currently being used in attacks. So we'll have to monitor for those. We'll take a look to see if our environment has any of that going on. And that kind of corresponds with threat hunting. So one of the main tools we use is Slack. Highly recommend it. So it's our chat platform that we all use together as a team. We really don't use email all that much. It's mostly through Slack as much as we can. And we have not all of our alerts, but many of our alerts going to Slack through APIs and different other ways. So I wanted to show you a few of our alerts and just kind of go over them. So let's see, ludicrous speeders. That one is where when you have someone logging into the VPN, say from Iowa, and then 5 minutes later they are in New York. Well, that doesn't make sense. They somehow traveled, I don't know, 1,500 miles in 5 minutes. That's not physically possible. So we'll investigate alerts like that. The Office 365 compromise detected. So what this is when people send us emails, we get a message in our Slack saying what email could be possibly phishing and to investigate it. We also have that with our tickets too. So whoops. We have our tickets also coming in. So we get alerts when we have a new ticket assigned to us, which is super helpful because I don't like being in a ticket system and I'll forget to look. And then, you have an old ticket there. One of the other things we have is our IDS, which is our FireEye NX. IDS stands for Intrusion Detection System, just in case you don't know. And so what this does is it monitors the network traffic and will just send us alerts for anything that looks malicious. So you can see I fuzzed out the domain, but it was an IOC going to a .xyz domain. So kind of suspicious just because it's an XYZ domain, and then the source and the port. And so we just click that link and we get the full report, and we're able to start investigating the alert. This domain lookup is basically anyone who goes to a phishing domain after we block it before or after we block it, we get a message saying this user went to that domain and to investigate to see if we need to reset them since they possibly got phished. And then we also have commands that we can do in Slack. So some of the things we can do is we can reset users. So any passwords we need to reset really quick, we can just type it in chat and it's done. We can block emails and we can block domains, all from Slack, which is a great feature to have. So I don't want to try, I'm not trying to get all tool heavy on this, but this is just a good way of showing everything. So on the left, we have another Slack alert. This is from Splunk that's going to then the Slack. And so all it's saying is we just have a high priority alert. And so this could be anything from persistence to a possible exploit to just malware. So I wanted to I took a screenshot of like some malware or exploit we found in our environment. And you can see the observed behavior, which is also odd behavior in my opinion for most software. It creates an executable in the temp folder. It changes its settings to hidden. And suspicious scripting file in a temp folder executed by the command line. All very odd behavior. And this is kind of like putting it all together. What we have is we have what processes are running, what IPs I went out to, and what domains. So this is all collected in a nice centralized spot for us. For you, it's not going to be most likely unless you have a pretty mature environment. A lot of this you are going to have to get separately from logs or flows or DNS records. So a little bit more of what we can do and what other organizations can do. When you get an alert, one of the things you want to do is you want to be able to contain the system quickly because any malware or exploits or hackers can move through an environment very quickly. So you want to be able to request containment or like block the port to stop them as fast as you can. And then there's a few other things that's really great for IR that's in here, such as like full memory and full disk to get all that for more processing later, and then a standard investigation detail, which is also you can write a lot of this with scripts, and there are scripts out there that just will pull this. And then IOCs, it's kind of more what I was talking about earlier. IOCs are indicators of like an odd IP or a bad IP or a bad website your system went to. And so it's just kind of this one showing it. The file right is this helper.sig. And then I wanted to throw in these two interesting alerts. This is from our IDS. Now these alerts happen between 30 minutes within each other. And what's interesting is if you can see it, this is the same message from two different IPs. So what they're doing is they have a different infrastructure for scanning our environment. And you can kind of get a glimpse of that by this, because these are the same exact attack patterns from different IPs. And luckily, this was not a successful attack because we don't have SMTP enabled on these machines. And this was trying to allow some sort of not encryption, some mining on the system. And then Splunk is our SIM, so our security information management. And Splunk's amazing if you can use it. You can also use ELK, which is also a log aggregate. And so what that does is you just put all your logs in, and then you can start building out alerts or I mean, literally almost anything you can think of that you can parse that data. So one of the things we do is when we enter in like an IP, we can have all the information of where it's at. And then we can also look at all the data sources such as Active Directory and firewall events, any alerts it has, any epic messages or alerts on the system. And then another thing like we look at is like flows. So flows is really great for finding like command and control servers. This one's kind of interesting. This looks like a command and control server where you have an external IP and an internal IP that's just keeps like using just saying a hello to this IP. And what it was just a ping. Someone was just testing to see if a web server was up. And then open source information. This is really some of the best information right here. AnyRun, which is a malware like running sandbox. VirusTotal allows you to scan exe with or different files that can be scanned by aggregate amount of different scanners. So I think VirusTotal has 58 scanners when you scan exe. And then URL scan, which is great for just scanning URLs that you don't want to go to, because if you have an a website that you don't want to go to, that you can access it through that. And then Abuse IPDB, that's a great site for seeing any known bad information on an IP. Then of course, like Google and Twitter, CyberChef, I'll be showing that off here in a minute. And then Shodan, which is a vulnerability scan engine, and then blocks. So I just wanted to do like a quick demonstration of like Emotet, which is a very common piece of malware that's been around since 2014. It's a banking malware that attempts to steal all your information as much as it can. And so this is AnyRun, what I was talking about earlier. And you can see this you can use this on a free account too. So if you have any files that you're interested to see what they do, you can do this and really dig in really hard. So what I'm seeing here is someone sent this Word document to enable macros behind that. And then when you hit enable macros, it pretty much will spill out all this command line gibberish, which is a encoded message for PowerShell. So with this information, it's kind of hard to tell what the heck's going on without knowing. And you can kind of see in here, it gives us warnings of what it's doing. So it's executing a PowerShell script, and then it's executing the Windows management interface. But what we can do with this encoded message, we can take it to CyberChef, another site I was telling you about, and we can start breaking it down to see what it actually is. So we know it's from base 64 because all PowerShells, well, I don't know if all PowerShells encoded base 64, but this one is. So let's turn this one on, and we can start getting some usable, readable characters now. And if we just start replacing everything down, so we're replacing this plus and this other plus with just nothing. And we start breaking it down more. We start getting more usable sites. And then for this final one, I did not make this. I found this on a blog. And this is a really nice part. It breaks it down to each individual link. And so what you can do with those links now, one thing about Emotet is it has multiple links for it to check through. And so it's it always has a possible entrance into your computer with having such a robust back end of compromised sites. So we can take one of these sites. This probably won't work because most of these get taken down so quickly, but we can do the URL scan on here. We can see what might be happening. I haven't done this, so this is live, so I don't know what's going to show up. Does take a minute. Okay, well, that might be down since it's taking so long. So I'm just going to assume it's down. Yeah, so that's how you can break down Emotet malware pretty easily with open source tools and free tools. And then, so after all that, you've determined a system's compromised. What do you do? Well, this is like the short, sweet summary. So you found an infected system. What you want to do is contain the system or disable the port. Now, that's not always recommended because if you currently have traffic running in and out, you're going to probably want to know what that traffic is. So our environment will be fine if we disable the system because we already have all that. So just keep that in mind. We then reset the passwords of the user, email the owners of the system for it to be rebuilt. And then we also ask the owners of the system and the owner of the system if there's any important data. If there's no important data on it, then most likely we're just going to rebuild it and call it a day. And then if there is important data, then we're going to have to start an IR case on the event. And then what you want to do is you want to start capturing the memory, all the logs you can get, and possibly do a bit by bit hard drive backup of it. Actually, I would recommend that if you're going to go to a court case, to have all these really well noted for your case and what you did, because you don't want to be in court and be asked a question, just say, I don't remember what I did, or why I came to that conclusion. And then you also want to look at if there was any exfiltration taking place. So like the flows we were looking at, you want to look at that, see if there was any spike after the initial compromise. And you also want to look at like the logs to see if anything was changed, like check the dates, see what was accessed, and go from there. I'm sure there's a lot more to add because every situation is unique, but this is a base, what I would call baseline forensics. And then you want to add notes to the case and then close the case. And so that's all I got for that.
All right, thank you, Adam. Yeah, great information. I thought especially those, references to some of those open source tools that you can use in SOC analysis is really really neat. So yeah, if anybody has questions for Adam, go ahead and enter them into the chat. There was one question that came in that was a little bit higher level. So is there a certain cybersecurity skill, coding, language, talent that you are looking for? And Jason responded there with Python, PowerShell, and JavaScript. And I would add to what he added, one thing that I think is becoming more and more important in security is those scripting languages and having some experience, because automation and integration with other tools is increasing all the time. So if you have those capabilities, in Python or other scripting languages to understand how applications can work through APIs and do all kinds of different things to automate, that would really benefit you. I think we had one more question here. How much of your time is spent on documentation? So that question for you, Adam.
Yeah, so I feel like there's some people in my department who spend a lot more on documentation, and they're like the backbone of our department. I say I spend probably, I don't know, anything new I try to write down in our wiki. So probably like an hour every 3 weeks for documentation, because we have it so well documented. There's so many people in our department that are always documenting things that are new. So they probably spend an hour a week, I'd say, on documentation.
Yeah, it's important. People usually don't want to do it. It's not a very sexy activity, but it's that situation where, a few weeks, months down the road, you're glad you did it, because you come back and share information with other people, or maybe you even forgot something yourself. So it's definitely a needed task to have. All right, let's move on here to our next speaker. So Jason Batani, who is an Information Security Senior Engineer 2 at Principal Financial Group. Go ahead, Jason.
All right, thank you very much. So just a little background on myself. So I've been at Principal for 7 years now. I've been in information security for longer than that. My background was in development. I was a developer for more years than I care to really share right now, but it's been a long time. So it was a nice transition over into info security. When I was at a previous employer, we kind of started a cybersecurity program for developers from the ground up and had a lot of success with that. I went on and did other things, then kind of came back into cybersecurity full time when I came to Principal. So I kind of have an interesting background as far as education and stuff. I actually went to school and graduated with a degree in marketing, so I wasn't anything to do with technology or information security when I came out of college. But I quickly learned that the company that I started with, they weren't really willing to do a whole lot in their IT department. So kind of out of necessity to try to figure some things out, I kind of got into programming, and that kind of evolved into the career I got into, getting into technology. So that's kind of real high level where I've got in my career. Did a lot of learning on my own and just taking some real relevant training courses and stuff along the way to get where I'm at. But just real high level. So my role here at Principal, I'm a static code security analyst, and what that means kind of in general terms is we scan software. We do a lot of scanning of software, and we have a lot of tools that we use to do that. And we do it as inconspicuously or conveniently as we can with the developers. So we use tools like Fortify or CodeQL. We used to use a tool called Veracode. We've investigated all sorts of other tools to do the static part of it, like Checkmark, Sneak. We're constantly evaluating tools to see what will give us the best, I guess, scan as far as finding the most vulnerabilities, accurate vulnerabilities, and eliminating as many false positives as possible, because what we don't want to do is cause a lot of noise for developers, because that just wastes their time and wastes our time. So on the static side, we're doing exactly what that sounds like. We are scanning source code. We also use what we call SCA tools, and those are software composition analysis tools, and they don't so much scan the actual source code itself. They actually scan the dependencies or the libraries that your code is using. And for anybody who's on the call who has written code before, you bring in a lot of shared libraries into that code. I've seen statistics anywhere from 80 to 90 to 95%. Your code is actually shared. And so this is becoming more and more important, and being able to identify vulnerable libraries and make sure you're on the latest and greatest and patched version is just hugely important. So we use White Source, which just recently rebranded themselves to Mend. We use Dependabot through integration with GitHub, and again, we've used Sneak a little bit there as well. But at the end of the day, our goal is to ID vulnerabilities and provide recommendations to developers on how to mitigate those vulnerabilities and prevent those from coming back into their software. So we kind of have a twofold approach where our tools help them to identify and then recommend remediations for that. But we also are responsible for some of the software training that the company uses as well. So I'll get into that in a little while. But as far as like background, skills, and responsibilities for our position, it is incredibly broad. To say we wear many hats is probably an understatement. I'm not going to go through all these different things that I am showing on the slide, but I thought I'd just kind of throw some of these out here. I mean, we do a lot of different things. I don't know if it's this way at other companies, but like I said, my background is in development. I got an application security, so coding skills, database skills, DevOps, infrastructure, networking, on-prem cloud. We do all of that. We're kind of responsible for managing our infrastructure with our tools as well. So we have kind of an on-prem instance of some of our tools, and we also have a cloud instance as well. So we're dealing with a lot of different things. And just some of the tools that we deal with, Fortify is kind of our main SaaS tool right now, but again, we're always evaluating those tools. We're also using GitHub Advanced Security now. And again, anything we're doing with tooling, I think James said this earlier, automation is just hugely important. We try not to do anything manually anymore for the most part. If there's a task you're doing, more than a couple times throughout a day or whatever, we try to automate it as much as we can through scripting. And like I threw in the chat, we use a lot of Python, we use a lot of PowerShell for that, and it just helps us tremendously. Programming languages, again, we have to be able to either read or write intelligently in these programming languages. A lot of what we do now, we're not writing so much like high level code with like the Java and the .NET anymore. It's more scripting to automate stuff, but we have to be able to read, analyze, follow that whole flow of the code to be able to work with developers to make sure that we can really give them intelligent suggestions on how to fix that code if the tool itself isn't providing them with good suggestions. We have like a lot of libraries and different things out there to provide coding examples in their specific language. So there's a lot of programming languages that we deal with. And plenty of other technologies we use. We're in both, or actually all three the main cloud providers, so AWS, Azure, and Google Cloud. We use Postman a lot to interact with APIs, and then kind of we'll evolve that into scripting. A couple of different databases, actually. I mean, there's more than just SQL Server and MySQL, but those are kind of the main ones we use for our tooling. Proficient Windows and Linux, all sorts of source code management tools, just because we're a very big global company and have purchased other companies. And so you kind of inherit what they're using and try to evolve them into a corporate standard. But again, we have to support all these with our integration with our scanning tools. And we do a lot with both the source code management tools as far as integration and within the build pipeline. So there's a variety of those as well. So as far as who do we interact with on a daily basis, I mean, we support over 1,000 developers worldwide right now. We have a number of different business units. Again, they're kind of global. Each one of those business units has their own security team, which may be, DevOps people, maybe developers, maybe some security people, but with our development staff being so huge, we typically now go through more of those security teams and let them deal with their developers, but we still do interact with those developers, but just not as much. Again, the DevOps teams, and then we work with our broader team. So with the two other gentlemen that are on this call, our teams are kind of divided up into that different structure too. We work with those other teams, whether it be pen testers or like our network vulnerability people when they find different things. So we get involved with all those as well. So when I was asked to do this presentation and kind of describe, what a typical day is like for us, I had to laugh because we don't really have a typical day. I mean, we seriously are doing so many things on so many different levels. I don't know which slide describes what we do best, but I think they're pretty all encompassing here. I mean, we do a lot and are juggling many things. So just to give you an idea, I decided to kind of jot down what I did the other day. So, what you may call a typical day, I just called it a Wednesday. So I picked Wednesday and just kind of logged what I did that day. And again, I'm not going to go through every one of these, but seriously, I will get on and kind of catch up on emails. And we use Teams for like our instant messaging, and we have all sorts of team channels and everything. So getting caught up on that, trying to put out fires there, addressing any pressing issues from there. We use Jira tickets for our ticketing system. So we have, requests coming through, and it's kind of new to our team. We've been a very small team for a long time. It was just myself and another person. Now there's 3 of us. And so trying to prioritize and not get interrupted so much, we're using those. So kind of we'll go through those and, what is my highest priority, pick on that, start working on that. oh, by the way, get a call or an IM from somebody. We need these metrics. We need these metrics now. Can you give us this reporting? So I kind of get disrupted and do that. Oh, one of the guys on our network vulnerability management team contacted me because an alert came up for our Fortify infrastructure because we have an old version of Tomcat out there. Well, we've got multiple servers where we manage that multiple environments. So that's, oh, by the way, you have to have this done by July 1st. So you got to kind of put a plan in place for that. We had a request out there for one of our white source scans. Team was looking at a few of their repos out there, and they felt that a library was getting misidentified by a scan. So that's a matter of kind of stop what you're doing and take a look. We have to pull down the code. We can run a scan manually, or we can pull it into like a test version of GitHub that we have and run it through our automation and try to get a comparison of, what's white source seeing as far as that library goes. Why is it maybe misidentifying that library, and working through that? It involved getting the rest of my team involved so we could all look at it. So we start looking at multiple tools to identify that, and eventually evolves into opening a ticket with the vendor to kind of see what's going on. So I can go through all these, but that's kind of real quick, kind of what we're going through on a daily basis. And I kind of jokingly put in there, by a little before 10, go get breakfast, take a breath, and kind of get back to it. I mean, seriously, it is kind of crazy on a day-to-day basis. So I mean, it may seem crazy listening to that, but for me, I mean, I like it. I like the variety. We constantly get to work on a bunch of different things. We had to learn a bunch of new technologies because, I mean, we didn't have any experience with Azure or AWS probably 2 years ago. We spun up our whole infrastructure for Fortify out in Azure a few years ago. And man, I mean, it's just so slick what we're able to do out there. And we're eventually going to evolve completely off of our on-prem infrastructure for that. So it's kind of neat there. So most of our stuff is proprietary, so I had to kind of take some screenshots of things and try to share it and try to knock out as much of our proprietary information as I can. But one of the things we have written on our team is what we call our security scanning service. And again, our whole goal is to try to get out of the way of the developers and let our scans run where it doesn't interfere with anything they do. They don't have to create any type of, like, if this is from GitHub, so the pipeline there is a GitHub action. We're trying to prevent them from having to create an action to implement our scan. So anytime a developer does a code commit to that source code repository, it's going to kick off one of our scans. It does that independent of everything, but it will run a check through GitHub, and then it will eventually create an issue right in GitHub, because we are trying to get our information as early as possible to those developers so they can act on it. It used to be back in the day, really probably 7 years ago when I came, we were running all these scans ourselves on our team. And so by the time we ran it, it might have been at, I'm about ready to deploy my code to production. So we're trying to do it, each commit. So this information is in front of the developers. They can address it early, they can learn from it and not make those mistakes going forward. So the earlier we push that, the less costly it is for them to fix it. So we're trying to do that as conveniently as possible. A lot of other tools would create an issue for each vulnerability found. You can kind of hopefully see on my slide there that we try to summarize those issues in one kind of main issue there where developers can see that. And we have a link to the scan out in Fortify where they can go just click on that and see the information out there. Again, we're just trying to get out of the developer's way so the scan's happening and they're not involved with it until they need to be involved with it. I would say at this point, probably 99.9% of our scans are automated. We will do manual scans, kind of the example I alluded to earlier, where we had to pull down the code and kind of look at, why was white source having issues. Most of our scans that are manual are more troubleshooting or maybe a language that we can't automate at this point. So these are kind of just two examples of what our tools will show. So the one kind of in the background here is Fortify. So it's going to show the vulnerabilities. It's going to break them down into criticals, highs, mediums, and lows. Developers do have opportunities to go mark things as not an issue if Fortify flags things that really aren't issues. Fortify does a really good job of flagging anything that has password of any kind in it, even if it's not a password, it's critical. So it is important for developers to have that avenue. Our team then does review those and make sure that those aren't just being flagged as false positives because they don't want to fix them. In white source, which is the SCA tool, which is scanning the dependencies, kind of doing the same thing. It will flag things as high as criticals, or I'm sorry, highs, mediums, or lows. You can see that over in this section here, the pre-vulnerability alerts. I didn't get into the details of that, but basically it'll give it a CVSS3 score of anywhere from 10.0, which is the worst, on down to, I think, probably 0. I don't think it does a 0, but probably 1 or so. But we flag on those, and we can set policies and everything to keep those vulnerabilities from getting into their source code. Same thing with Fortify. Through our build integration or through our automation with our security scanning service, we can block PRs from going to production. We can block PRs from being merged to that default branch. We can block things so the build breaks so they can't deploy that. So we're trying to really get in the way and prevent those from getting out there. Again, the automation is key. We are scanning about 1,800 different, I guess not different repos. We have 1,800 scans running on average on a daily basis right now because of our automation. And obviously we're a team of 3. I mean, there's no way we can do that manually. Obviously we'd need a huge team to do that. So the automation is just key there. And it's not an exaggeration that 99.9% of our scans are automated, because I mean, we just couldn't handle that load. We do have just a pretty huge infrastructure that we deal with right now. We manage between 30 and 50 servers between all this. As we migrate off of our on-prem infrastructure, that'll go way down. One thing that's really neat about what we're doing out in Azure with Fortify, scans run on sensors. And so, with 1,800 scans coming through there a day, obviously there's going to be a lot of volume that, kind of peaks and valleys. So we've written scripting through Azure to be able to add sensors and scale back those sensors as demand dictates. And so that's been hugely helpful, because typically, like in an on-prem infrastructure, you're going to have, say 10 sensors just waiting there for traffic. Most of them are sitting idle during the day. We can scale back to 1 or 2 sensors when it's really slow, and then scale up to 50 sensors if we need to. It works extremely well for us. It's been really handy, and it saves us a lot of money. So a couple other cool things, I guess, that we get to be involved with is like 0-day vulnerabilities. And by cool, I mean that's a lot more work for us. So you may have heard about the Log4j vulnerability that came about back in December. Came at kind of a really bad time for most of us in IT, because it was right around Christmas time, right around, hey, we're going to have a week or 2 off. And then, no, you're not. You're going to get to work weekends too. So we basically used our tool like Fortify to identify across our enterprise all source code or all applications or repositories that had use of Log4j. And for those of you not familiar with Log4j, it's basically a logging library that's pretty much used by any Java developer humanly possible. And with a company as big as ours, you have a lot of technical debt, and there were a lot of old versions out there that we had to upgrade. But we had a really good response across our security teams and across our development teams, and we're able to take care of that fairly quickly. We also get involved with data loss prevention, and what that means is we have people who will spin up their own GitHub repository or personal repo, and they will, for whatever reason, think they can copy their code out there. We have all sorts of teams that are scanning public repos out there, looking for any of our intellectual property out there. So we will get called into that from time to time, just because of our experience with being able to read code and so forth. So we get involved with that and help out trying to identify, is it actually principal's intellectual property, and who is the person responsible for doing that. One other thing we get to do is help with application security training. So we get to use some pretty cool tools. Secure CodeWire is kind of one of our main training tools, and it's a neat tool in the fact that it like gamifies how the training takes place. So you get to go in and compete against other developers. We run tournaments from time to time with our developers throughout the enterprise. So back before COVID, when we were all in the office, we would do tournaments on-prem, run them like, pretty much any other tournament you can think of that involved programming, where people would come to one central location. We'd have food, we'd have music, we'd involve, kind of our other areas that are in different locations as well through, various means. But it was a lot of fun that way. But now we do most of them virtually, and we offer prizes for like the top 3 finishers, for example. So we do these for various programming languages. It's really slick that Secure CodeWire allows you to pick, I don't know how many languages they support now. It's quite a few. I would say 20 plus. So we can write those tournaments. And so if I'm a Java programmer, I can take it, and I'm a Java Spring programmer, I can do it in that framework. If I'm a Java Struts programmer, because I'm really old like me, I can be able to pick it in that, but we can do it in .NET, in PowerShell, in COBOL if we want to. I mean, there's just all sorts of languages available to it, but it's a really handy tool. So just one other thing, as far as like what's next, for those of you who are in college trying to figure out things to do, I mean, attend as many conferences and trainings as you can. I mean, there's so many things available online and for free. Whatever you're interested in, go to one of those, meet people, talk to them, understand what they're doing, just really immerse yourself in that kind of thing. I mean, there's technology or programming languages you're interested in. Most of that you can learn really easily by just searching for it online. There's so many coding examples out there. Pluralsight, Safari, O'Reilly. I mean, a lot of those sites have just a lot of great content out there to help you with that. You're already doing an internship, so that's a really good feather in your cap. But take advantage of that opportunity as well to learn from as many people as you can there, talk to as many people as you can there, shadow as many people as you can. Just take advantage of it, because that's just going to be hugely important when you get out and are no longer in school. I mean, there's just no replacement for that hands-on experience. And really, I mean, if you're interested in development, I mean, build apps that you find useful. I mean, anything that you see a need for, anything that you're doing repetitively, automate it if you can. So that's my 2 cents worth. So I'll stop now.
All right, thank you, Jason. Yeah, great information and some great advice there on that last slide too. And as you were talking, I'm thinking about some things that are becoming more important in cybersecurity. I think application security is one of those things. We're starting to see that now as one of the foundational pieces of a security program. Or in the past it used to be network security, and then it was vulnerability management, and then it was SOC functions. So these things keep building up into the foundation of security programs, and I think that's becoming the case with application security. And I would advise interns, you will have a lot of opportunities if you have some understanding of programming logic, and what goes into a CI/CD pipeline. And then also understanding security principles. I think that's if you have both of those skill sets, that's really going to open a lot of doors for you. So if anybody has questions for Jason, please enter them into the chat, and we'll try to get back to them. But for now, let's move on to our last speaker for the day, which is Trevor Kims, who is a penetration tester at Pradham. Trevor, go ahead.
Awesome, thank you. So I don't have any slides today, but I thought I'd just kind of go into what I do on a daily basis. I'm a recent grad from Iowa State. I graduated May of 21. So kind of been in that world of in the college space, and what you can do looking back, especially from what I've seen in the industry for my even just short time. What you can do and what you can do to try to further yourself in the security space. That's what you want to go into. So Jason hit it on the nail on the head earlier with his slide with all the, especially the dog on fire was saying, this is fine. Every day is different. And when I walk in the office, sometimes I think I'm going to be working on something, and it goes a completely different direction. So as a penetration tester, I get exposed to pretty much everything under the sun. So that can be physical infrastructure, such as SCADA systems, ICS. So you're talking power plants, water plants, you name it. And then also some of the more like network side. So typical small, medium, large corporate networks, a lot of Windows environments. And then also those cloud environments that are starting to pop up and be more common. And then a whole other variety of like web applications and all different languages, all different server types, you name it, I've probably seen it already. And that's where the complexity comes into, well, how can you prepare yourself for seeing everything? I will say I see a bunch of languages a lot that are completely new to me. I've never seen them before, but just knowing how to understand basic code, even just Python, gives you a huge leg up. Because if you can read Python pretty successfully, and then you try to go read C, you're not going to get everything, but you're going to get a lot. And while I don't usually do a lot of code review, it's very important to understand how the logic of a lot of those applications work. Going into kind of what happens on a daily basis here, a lot of times the engagements that we do, usually that's what we classify as a vulnerability scan, a penetration test, and then sometimes a web application scan and penetration test as well. So usually the engagements start out with a vulnerability scan. So that would be something along the lines of using like Nexpos or Qualys to perform those scans against infrastructure. So that can be, again, pretty much anything under the sun. That can be authenticated or unauthenticated, depending on what kind of visibility the client would like. And then once those scans complete, that gives you an initial view of the environment. Some engagements, you don't use any scanning tools. You just kind of wing it, and I like to call it living off the land. So find something, and if you can get into it, start there and pivot around. So once those vulnerability scans kind of kick off, then it goes into the more manual testing. So a good example of manual testing would be, for example, Active Directory attacks. So as I was saying earlier, a lot of corporate environments are Windows-based. So that is Windows Active Directory. So if you would like to learn something new, Windows Active Directory is going to be around for a long time. That is something that if you want to learn about the corporate world, learning what group policy is, group policy objects, how permissions work, that gives you a huge leg up, even on just the blue team side. So if you don't really, you're not really interested in the I want to be a bad guy kind of penetration tester, you can definitely learn some of those group policies and apply them in a systems administration role as well. But that also gives, for example, penetration testers a little bit of a leg up, because if you know how ACLs work and you know how group policy interacts from the blue team side, you can kind of translate that over as an attacker would. So to give an example, the other day, just a few days ago, my coworkers and I have used a certificate vulnerability to get credentials. No passwords were needed other than the initial password for a super low-level user. And we were able to chain together an attack and get full domain administrator rights, which is the highest rights in the environment. So not all engagements are like that, though. A lot of them, if you step into a more mature environment, you're going to get shut down by the tools Adam was talking about pretty quickly. So a lot of engagements that I do, you try to be loud and fast, you will get shut down very quickly. So in addition to that kind of stuff, how can you prove to the client that you've done all this? Well, you have to do a lot of reporting. So reporting can be anywhere from a kind of Excel file, CSV file that has findings in it, to a more kind of polished technical report, all the way up to an executive level report that, for example, the C-suite might see. So your CEO, CTO, CISO kind of people want to see. Technical writing is huge in the cybersecurity space, especially even for basic penetration tests and vulnerability scans, because how can you kind of convey those findings to somebody that has no technical experience at all? I've personally been on calls with somebody that has no idea the technical side of things. They don't really do an IT role. They're more of like let's say a vice president. They are usually, that's more common with smaller clients, because you might not have a dedicated IT staff. You might have an MSP, managed service provider, that does all their IT for them. So being able to, one, convey that information is very important to a non-technical user, and then also be able to break it down. So a lot of times I have no idea when I initially find something, and spend a little time researching it. Just recently, for example, I was messing around with .NET, So .NET, the .NET framework, and some of the older versions. And I went into some great depth into how security works, and for example, the view state variable, if anybody's messed with .NET, and kind of going down that rabbit hole of how the security works and how those vulnerabilities are affected. And that can be huge if you're talking to a developer that understands that. So that can be important, but it's equally important to be able to explain it to a non-technical user or be able to write it in a technical report. Another big thing is connections. So up at Iowa State, I was a part of the information assurance student group and participated in a large number of cyber defense competitions. So to kind of further my experience up there, a great use case for kind of connections would be seeing what you can get exposed to up there. So there's a lot of technology out there that's very expensive. For example, a lot of hardware that penetration testers could test against costs thousands of dollars. I don't have access to it. I don't have the budget to buy that kind of thing. But if you know somebody, or you know somebody that knows somebody, you can get a tour of a place, borrow a piece of equipment, and those connections really are powerful. And even at the cyber defense competitions, it's not just everybody attacking each other. It's a lot of blue team versus red team. So the blue teams kind of come together and try to defend themselves against the red team. And there's a lot of great connections you make. And then the red teams, they're not bad people. They obviously are attacking your network, and they want to get into your servers. But at the end of the day, they come and they have a nice presentation. They say, here's how we did it. Here's what you can learn for next year. Go home, take these things that we've done against your network, and learn from them. I learned so much during my time at the cyber defense competitions. If anybody would like to do it, Doug Jacobson is the lead up there at Iowa State. And they have them, I think, twice a year, one in the spring and one in the fall. They might have a little bit more now. COVID kind of threw things upended the entire process, but it's nice because you can also do them virtually. But going back to the connection side, I had I worked previously in Ames and did kind of a systems administrator role. So I was exposed to that Windows kind of environment, and then moved towards the Linux side as well. And the management was big because once you kind of know the blue side, you can kind of exploit it a little bit more on the pen test side, the red team side as well. So going back to even further, back to like what my day looks like, we don't just do penetration tests and vulnerability scans against environments. What's really kind of the fun part is actually being the bad guy. So an example of that would be physical engagements. So for example, I've done multiple physical engagements where you go on site and you try to break into a building. That could be cloning badges, that could be trying to talk your way through the front door, following somebody through the front door, getting up on the roof. Pretty much anything's fair game at that point. So that could be very valuable to clients because, for example, a lot of clients have very sensitive information that they're protecting in their buildings. And a lot of clients only think about, for example, the Wi-Fi security. Well, if the Wi-Fi security doesn't really matter if you can just walk in the front door and wheel out $1 million worth of product out the loading dock at 2 a.m. and no one's going to notice. So that's another side that's very important. And it gets a little bit kind of in a gray area because it's not quite digital sometimes. It's a lot of what they call social engineering. And that's where you kind of have to learn to think like a bad guy. What would a bad guy do? They have no ethics. That's why ethics is very important to learn as a red teamer, because I know a lot of things that could do a lot of damage, but I have good ethics, at least I think so, that I wouldn't use those in a bad manner. So kind of thinking about ethics alongside that social engineering is important. Iowa State has a class on ethics that cybersecurity engineers like myself had to take. It goes into very good detail and kind of talks to people in industry. However, you don't need to take a class to learn about ethics, obviously. It's just kind of knowing right from wrong, but it gets a little bit more complicated than that, obviously in the security world. Going back to social engineering, we also do phishing emails and phishing calls. Technically, they're pretexting calls. I'm sure Adam probably I would be the bane of him on a day with some of the phishing emails we send out, because sometimes they pass, sometimes they don't. And it's always kind of a yes moment when somebody clicks and enters their password, and then they get all the way through and they say, well, now you have to reset your password because you fell for it. Sometimes they work and sometimes they don't. Some people are really good at spotting them. Even I can make the best phishing email in the world and somebody would still catch it for a simple little thing like, oh, the period's not quite in the right place. Okay. So that's kind of the fun part of penetration testing and being a pen tester, is kind of customizing and designing those kind of things, thinking outside the box. Same thing with engagements. It's a lot of times thinking outside the box. Well, if I can't go in the system through the front door, let's try the side door. Let's try the roof and all that. So I know we're probably running up on time here, but oh yes, I see the question in the chat here. I can't see the entirety of it, but yes, I heard about that. And definitely after I started, we had a very long discussion about that specific case. From what I can tell, from what I've heard, it's mostly related to the fact that the state of Iowa hired them and the sheriff was unaware and the county was unaware. And they also did it outside of the hours they were supposed to be testing. That's just hearsay. That's from what I heard. But that's why scope is very important in testing. Scope is really big because, for example, it is very illegal to exploit vulnerabilities that you just see on the internet. And if, for example, you type in an IP incorrectly and were to exploit a vulnerability, that can be a very big deal. That's against the Computer Fraud and Abuse Act. And if you gain access to it, there's a lot of legal liability that you open yourself up to. But for the physical side, yeah, they were arrested. They sat in jail for more than a few days, if I remember. But yeah.
All right, thank you, Trevor. Yeah, very, very interesting. Both the the technical aspect of penetration testing, and as you were talking about in the second part of your talk there, right, the human element, because that's still where we're most vulnerable and probably will be for quite a while. So very interesting. Thank you. As Trevor mentioned, we are at time for the day, so I'll hand it back